An airport runway is 2 kilometres long. An aeroplane touches down at a point T and immediately starts to slow down as it travels towards the point B at the end of the runway. A marker labelled P is located along the runway. So there's a diagram shown here that depicts all of that information. And as the aeroplane slows down, the distance of the plane from the point A is given by the equation x of t equals c plus 100t minus 4t squared, where t is the time in seconds after the plane touches down, and c is the distance of the point T from A. So that means that this length here would be considered c. For part A, we're told that an aeroplane touches down 800 metres from the point A. So in that case, we know that our value of c for part A is going to be 800. So for part 1 of question A, we're asked to find the distance travelled by the plane in the first 5 seconds after touchdown. So the distance that the plane travels in terms of the time t can now be written as 800, which is the value of c, plus 100t minus 4t squared. So if we want to find the distance travelled by the plane in the first 5 seconds, we can evaluate that as being x of 5, which is the distance it's travelled after 5 seconds, subtract away x of 0, which is the distance it's travelled after 0 seconds. And when we do that, we find that that is equal to 1,200, subtract 800, which is equal to 400 metres. Therefore, after 5 seconds, the plane has travelled 400 metres. For part 2 of A, we're asked to write an expression for the velocity of the plane at a time t after the touchdown. So we knew that x of t was equal to c plus 100t minus 4t squared, where c was 800 for this case. And to find the velocity, we find that the velocity is the derivative of the position, so that's going to give v of t. And deriving this, the plus c, the constant value that's currently there, it would become 0 when we derive it. And then the plus 100t would turn into simply 100 when you take the power out the front and subtract 1 from the power. And doing that to the next term, we'd get 100 minus 8t as the derivative function, which represents the velocity. We then want the velocity after 5 seconds, so we're going to evaluate the velocity function at 5, which would be equal to 100 subtract 8 times 5, and if you evaluate that, you find it's equal to 60 meters per second. So that is the velocity of the plane after its touchdown for a period of 5 seconds. Next, we're told that the aeroplane passes the marker P with a velocity of 36 meters per second. And we want to find how many seconds after touchdown the plane passed the marker P. So what we want to do is we have a velocity of 36 meters per second. So we can solve v of t is equal to 36. Therefore, we're solving 100 minus 8t, which is the expression for the velocity, is equal to 36. And if we do that, we find that t is going to equal 8 seconds. So that's how many seconds after touchdown that the plane passes the marker P. For part 4 of part A, we're asked to find the distance from A to the marker P. So we know that it takes 8 seconds for the plane to reach marker P after its touchdown. So if we put into our position equation 8, we will find the position of P. So x of 8 is the same as evaluating 800 plus 100 times 8 minus 4 times 8 squared. And if you evaluate that, you'll find that that is equal to 1,344 meters from point A. So for part B, we're asked to show that if an aeroplane touches down before reaching the point P, it can stop before reaching the end of the runway. If we go back up to our diagram for a moment, we know that the distance of the point P from the point A was 1,344 meters. Therefore, the plane has 2,000 minus 1,344, which equals 656 meters to slow down. So that's the distance here that it has to slow down within. So that is 656 meters. In order for the plane to slow down until it stops, we need the velocity function v of t to equal 0. So that means that it will have 0 velocity, which means it will be stationary. For this particular question, the equation of the velocity function is going to be 100 minus 8t, and we want that to equal 0. And when we solve that, we find that t is equal to 12.5 seconds. So we know that it will take 12.5 seconds for the plane to come to a complete stop, for it to be stationary. So we can now find the position after 12.5 seconds of a plane, and it is going to equal, and for this part we're going to let c be 1,344, which is the greatest distance that it could be down the track. So we could land the plane before P, but even if we land at the point P, at the most it's going to be 1,344 meters down the track. So we're going to say that the position is going to be 1,344 plus 100 times 12.5 minus 4 times 12.5 squared. And when you evaluate that, that's going to be equal to 1,969 meters. So we can interpret that to mean that there will be at least 31 meters between the stationary plane and the end of the runway, which means that there is at least 31 meters left of the runway, which means that the plane will safely stop as long as it has touched down before reaching the point P on the runway.